Hi, welcome to Stair Tailored. My name is Jessica Mao and I'm with the University of Texas at Austin. This video is the first video of a 4-part series on how to multiply linear expression. And in this video, we're talking about algebra blocks. Now, before we get started, I want to bring your attention to the use of multiple representations. In her 2017 article, Tricia Strickland talks about the use of CRAI, which stands for Concrete Representational Abstract Integrated. And here you see Concrete Pictorial Abstract, or CPA, and they mean the same thing. So these multiple representations help support students' understanding of mathematical concepts and their relations. So it is important for students, especially students with mathematics difficulty or disabilities, to use these tools to enhance and reinforce their mathematical reasoning and understanding. And now we're going to model with algebra blocks. Before going straight to modeling with the manipulatives, we encourage you to first take some time to introduce the manipulatives to the students and allow them to have a chance to understand how to use them properly. From this, you can then clarify when mathematical relations are represented through the tools. So the algebra blocks have 3 components. We have this bar, which stands for x, the variable x, and the square, which stands for x squared, or the variable x squared. And these little q's represent integer constant. For example, this group of q's represent the constant 4. And just as a note, students might have some misconceptions when using these manipulatives. So it's important to give them the opportunity to explore and clarify with you, the teacher, on how to use them. For example, students might think that 3 of these cubes is the same as 1 bar, or that the bar represents the constant 3. But this is not true. As you can see, they're not the same. So be sure to clarify x bar really means the variable x, which is an unknown, and it's not a value. When we introduce the manipulatives, it is important to give students a chance to see some examples. First, we can show students how to create the expressions 3 plus x, or x plus 3. To do that, we can use 1 bar, or 1x bar, and 3 constant, or cubes. This will represent the expression x plus 3. Now, this corner piece right here represent the mathematical relation when we multiply. When we use blocks along the side and the top, they become the 2 factors that we use when we multiply. Anything that forms inside the corner piece is a product. So for example, we can show students how to multiply 2 by 5. So we're going to put 2 cubes up here and 5 up here as our other factor. We can then show students how these 2 factors set the boundaries for when we multiply. See, when we fill in the product, we're going to look for 2 things. First is that our product fits within the boundaries of the factors, and the second is that the product makes a rectangle. Let's see. So we can see that 2 times 5 equals 10, where we have the factors of 2 and 5. And when we check the 2 rules for using these manipulatives is that the 2 and 5 form the boundaries for 10, and that the product is a rectangle. So here we've modeled the multiplicative relation 2 times 5, where 2 and 5 are the factors here on the side and the top. And that gives us the product 10. This is also a really good opportunity to talk to students about the commutative property of multiplication, in which switching the orders of the factors will still give us the same product. So if I have 5 on this side and 2 on top instead, we can still see that the boundaries and that the product are the same. So the boundaries are the same, and the product is also a rectangle, and the product remains 10. As you can see, students get to see the mathematics when you use manipulatives. And a sign of strong representation is that it represents the mathematical relation accurately and clearly. In this example, we are representing the multiplicative relation between 2 integers. So you can ask students to reason whether they represented this correctly by pointing out this rectangle, and students might wonder, why am I always going to get a rectangle? You can invite students to think about the relation. What does multiplication mean? In conversations, you can bring in the definition that multiplication means groups of. So in this example, we have either 2 groups of 5 or 5 groups of 2. Let's say that a student models this relation and ends up with something different, like this. This is where we can ask students, again, what does it mean to multiply, and is that reflected accurately in our representation? Do you see 2 groups of 5 or 5 groups of 2? When introducing manipulatives such as algebra blocks to multiply, take some time to reinforce the concepts of multiplication and multiplicative relations between 2 factors by having planned examples and non-examples. Thank you for watching this They're Tailored. Now check out our part 2 of the series to learn how to multiply linear expressions using positive terms.